All right, thank you very much for the invitation, and it's my pleasure to join online today. I'm going to present our project, which is called SecureUAV, energy efficient malware detection in unmanned aerial vehicles using AI models. So that's the cooperation between Christiania University College in Oslo and Andrii Aeronautical University in Florida, US. So the whole ambition or the goal that we put originally in this project was to develop a platform and let's say a framework that can be used to increase the cybersecurity awareness when it comes to operations of the drones and unmanned aerial vehicles. The challenge that we saw was that in most of the cases when there is a communication between drones and operators, it's a lot of information coming. I mean, I'm not talking about videos, but also about different types of telemetry, like speed, altitude, GPS data, and so on. We didn't see anything related to cybersecurity or cybersecurity awareness of what is actually happening in the drones. And that's the idea that we put forward in this project together with Hobing Song from Andrii Aeronautical University. So the whole idea was to utilize, first of all, capabilities of the drone platforms, because in some cases we have, for example, lower end platforms that are using firmware. Sometimes we have a bit higher end platforms that are using OS-based capabilities, like for example Linux or some kind of like ported versions of the Linux. And the idea was to see if we can actually gather the information and to provide let's say lightweight AI agent that can help to to detect that something is going on, like for example like CPU utilization, number of processes, I don't know, a number of, for example, files created and so on. So that those can be indicators of attacks, or those can be indicators of computer viruses. The project was from June 2022 until November. So that was technically quite a short time frame, and we planned different stages where there was a bilateral visits between US and EU partners, and also, let's say, participation in the experiments and participation in the analysis of the requirements and of the frameworks. So we had two visits to US in August and in November. The infrastructure that we acquired prior to this project was a collection of drone platforms. So there was a number of drones, quite popular drone platforms like DJI. For example, we also used things like X-Racer and different quadcopter frame kits that can be used, for example, to build and to design a quadcopter itself. We also acquired a few flight controllers like Navia 2. So this is just an expansion board that puts on top of Raspberry Pi. There was a Pixhawk. It's a controller or autopilot kit. And there was also a Krios flight controller that we acquired. We also got some of the measurement equipment. So it was both for radio frequency and also for current consumption. So that was one of the let's say experimental part that we did. So that was let's say a sniffer. We had Wi-Fi Pineapple for the Wi-Fi communication that was used, for example, in Raspberry Pi experiments, and also we acquired a power profiler kit. So that was for measurements of the current. So what kind of current or power is drawn by the board when different stages are performed. So we noticed that in some cases this board actually failed to collect the necessary let's say results, because it had limitations of 1 ampere, while for example Raspberry Pi can can draw up to 2 and 3 amps. So we had to use a little bit more advanced setup in that case. We also investigated different platforms like Raspberry Pi 4B, high-end. We also had Raspberry Pi Zero, and we also looked into Arduinos and ESP32. So some of the platforms that I mentioned, they have let's say proprietary or closed source software like firmware operating system, so we can't really let's say reverse engineer this part of software in the short period of time, but at least we were able to resemble how the drone was operating. A few KPIs that I'd like to mention, and that was the pillars in this project, is first of all, the AI data processing model requirement specification. So we analyzed together with SongLab what kind of requirements, so both functional, non-functional, can be put forward if we want to design such AI agent system, and also telemetry protocol to exchange, for example, using a MQTT together with JSON serialization format and so on. So that was first part of the project. So we analyzed hardware that we had. We designed these requirements. The second part was experimentation with Linux-based OS platforms, like, for example, Raspberry Pi that is connected to Navio too. So that's obviously Linux-based. And there are different indicators that can give an understanding of what is happening actually in OS itself. So it can be a list of suspected malicious files using Aircraft Hunter. It can be system load, a DDoS or DOS indicator. It can be memory consumption, irregularities in CPU load, a number of processes, and suspicious file system indicators. So this list is not extensive, so of course we can collect many more, let's say, indicators while not overloading the system itself. We also looked into MQTT protocol because technically it has a very low overhead. So I think the lowest packet can be like 2 bytes. So if you want to transmit such cybersecurity awareness telemetry, then it's the best way forward. We also looked into co-op protocols for later stages, for example, of our collaboration. That can be the way forward. If, for example, we have several drones that are flying in this vicinity, then they can exchange some kind of information. So that was the concept that we designed. So we have on the left side is the main functionality, so mission critical functionality. Different types of connectivities like Wi-Fi, Bluetooth, 433 megahertz, so 2.4 gigahertz. On the right side, this is our, let's say, a middleware software that can be integrated using AI agent, plus so-called cybersecurity telemetry that we can exchange with the drone operator. And the KPI 3 is the operation actually of such agent using, for example, Raspberry Pi. We noticed that there is no significant overload when it comes to operation. Like, for example, if we have a trained AI model that can be transferred to drone, then there won't be much overhead while maintaining and running this particular model. When it comes to the battery drain, because it's very important to consider the overhead, the power overhead of the drone. So we also didn't see that, let's say, a dramatic battery drain. Of course, there was an increase in power consumption in some of the operations like AI training, for example, and deployment, but still this is feasible. We also looked into several data sets, like, for example, IT23 dataset, HIT dataset. So those have malware tags that are quite relevant. When we have a different agent connected to the internet. I'm sorry. So I'd like also to say a few words about NSF grants. Hobing Song, he worked for a few years already with the UAVs and cybersecurity UAVs. They built UAV platform for education and let's say competence development. So that was a matching grant from the side of Andrii University. So we have a few links and that I wanted to demonstrate on this slide. So we published an article on Christiania, so it's our university magazine that promotes research, let's say to a broader audience. So they published an article in August about it. The way forward for us is we are currently working on the Horizon proposals with the deadline in April, together with US partner SongLab and also a few partners from Finland and Croatia. So that actually we're planning to use let's say acquired knowledge platforms and experimental results in the future application for Horizon. Yes, thank you very much.
Thank you, Andrei. The Embry-Riddle, did they apply to the DCL as well? I think they, if I remember correctly, I think they did on top of their existing NSF grant.
If I remember correctly, yes, they also sent an application.
Okay. So you don't really know, because I'm sure if Deep were here, he'd probably ask, you know, whether the process was easy or not easy. You don't recall offhand whether it was straightforward or not?
I don't have the details, unfortunately.
Okay, no problem. Yeah, as far as we know, it's been fairly smooth, especially since the NSF allowed the U.S. participant to use your proposal as part of their submission process, and there was only, I think, 1 or 2 extra tables that they had to fill in. So I think it was pretty straightforward, but you know, it'd be interesting to hear if there's any feedbacks. So thank you for that.
Thank you.
Does anyone else have any questions?
Also here. Oh, Sally, please. Let me give you the microphone. So we have a question here in Pisa.
Hello, good morning.
If you want, you can also.
So I'm the guy who asked many questions.
It's a good.
My question is, what's about this energy reduction when you are trying to energy saving? How you are? I didn't get it. How when you explain
it. So the energy consideration was part of the KPI 3 when we looked into the overhead, because I mean we can deploy, for example, AI training. We can do AI training in the cloud and then transfer it to the drone platform. But for us, it was more critical to see what's the overhead, because if the drone has, let's say, a flying time of 20 minutes, and then you deploy your AI model and then it flies like 10 minutes, this is not, this is not feasible. So for us,
the goal, I would say the goal of the drone is to just kind of stream images.
There are different missions, like they can be used, for example, in the reconnaissance phase. They can be used, by photographers. They can be used in some national security missions. So it's all types of drones that are available there. And there are a lot of applications.
The idea that I have in mind is to make, and this connect about the project of yesterday, is to make these drones as AGI. It means that the drones that we make them very smart, to be able to take decision and to be able to send only the digest or the gist, to not waste energy in sending and transmitting.
Yes, to reduce the energy that can be used, for example, by such solution, AI solution, but also to deliver this cybersecurity awareness, or let's say the telemetry, so to speak.
So I think that's what you're doing is very. No, it's not me. So we can perhaps I can send you an email to discuss about the connection between connected autonomous vehicles and the drones.
Of course.
Listen to me.